Hello Math 3 students, this is the day 5 of our Unit 1 and this is the inverse functions lesson. This lesson covers quite a few pages. It covers pages 10 through 14. So those are the notes that you'll need for this lesson. Inverse functions are not, sometimes we think of them as opposite. They're not exactly opposite. One of them undoes the other one, and I'll show you what I mean by that. So these are just our objectives for this first section. So we're going to look at graphs first, and then we're going to look at finding inverse functions algebraically. So the next part of your notes states that we know that a set of ordered pairs can represent a function. So if we have this set of ordered pairs, f of x equals x plus 4, and we take just some random numbers, like if we made an xy table is what they're talking about. We made an xy table and we used 1, 2, 3, and 4 for our xy table, and then we put in 1 for x and 2 for x and so on and so forth. If y equals x plus 4, then our table would have 5, 6, 7, and 8. So this is that first set of numbers, the 1, 2, 3, 4. This is the second set of numbers, 5, 6, 7, 8. And we could write that f of x equals x plus 4, and then our solution set for those particular values would look like this. The inverse of that same function where we had these ordered pairs. So if that function includes, if that function includes these ordered pairs right here, the inverse of that function would be f to the, it looks like f to the negative 1 of x. This just means the inverse of the function of f of x equals x minus 4. Those numbers would be reversed. So where we would have, where the first one had 1, 5, the inverse of it would be 5, 1. So the x would change to 5 and the y would change to 1. The first one had 2, 6. The inverse of it would have 6, 2. So you really, to find the inverse of a function where you're just given a set of ordered pairs, you just switch the numbers. So this was the original set of numbers, a set of ordered pairs. And then the inverse of that, which is denoted with this little negative 1 exponent, the inverse of that is just that the x's and y's are switched. Okay, it's basically the same thing I just said. So if you have, so this is your x and this is your y, or f of x, which is the same thing. F of x and y are the same thing. So if your x's and y's look like this, negative 3, 10, negative 2, 6, and so on, the inverse of that function, all you would need to do, these are your ordered pairs, so you'd have negative 3, 10, you would just switch them. 10, negative 3, 6, negative 2, 4, negative 1, 1, 0, and negative 3, 2. Okay, so I think a lot of times we think, oh, well, the inverse of a parabola, for example, if a and you don't have to draw this or anything, but if a parabola looks like this, the inverse of it would look like this, and this is false. This is incorrect. We're going to look at what inverse functions look like on a coordinate plane. So what is the purpose of an inverse? It does what we call, it undoes. It's what we do when we need to undo a function, and it will actually become a little bit more clear in the next unit, but we need to learn how to find the inverse of a function in this unit. So if you remember, we looked at the vertical line test and we said if a function passes the vertical line test, if you're looking at a graph and it passes the vertical line test, then it is a function. Now, when we look at inverse functions, if the original function, the first one, passes the horizontal line test, so exactly like the vertical line test, except on this, when we're looking at inverse functions, we look at the horizontal line test, then the inverse exists and is a function. And I'll talk to you more about that in just a minute. But we say that the function is what we call 1-to-1. So we're just going to fill this in, and then I'll talk to you more specifically about what this means and how to look for it. All right, looking at page 11, let's just do a couple of examples. So our directions say find the domain and range for the coordinate points below, then find the inverse and the new domain and range, use set notation. So this is our original function right here, okay? And then I'm gonna go ahead and put the inverse function right here. So if this is f of x, and these are the ordered pairs, some of the ordered pairs in f of x, then the inverse set would be, just switch them, -3, 1, 3, -2, 1, 5, and 4, 6. Okay, so the original function, let's look at that. The domain of the original function is just all the x values. So the domain, if we put it in set notation, would be 1, -2, 5, and 6. The range would be all the y values. So that would be -3, 3, 1, and 4. Okay, then if I look at the inverse function, the new domain for the inverse function is all the x values. That's -3, 3, 1, 4. And we'll notice that this set is the same as this set. So the range up here became the domain down here. And then the new range for the inverse function is 1, -2, 5, and 6. What happens with the domain and range? They switch places. So you can just write something really simple, like they switch. One becomes the other. However you want to state that is fine. I'm gonna leave this one to you because we just did one. So I want you to state the domain and range, the inverse function, which is all of them switched, and then the new domain and new range on that one. So I'm gonna let you finish that one. All right. So the graph of an inverse function. Like I said, we usually think, oh, it's just upside down or it's backwards. It doesn't work that way. What it does, though, the graph of an inverse function, what it does is it reflects across the line, not a x-axis or y-axis, but it reflects across the linear parent function, which is y equals x. So that's this dotted line right here. And then this function here and this one are inverse functions. So see how it's reflected across, they are mirror images of each other across this line, okay? So they're not mirror images across the y-axis, they're not mirror images across the x-axis, but they're mirror images across that line y equals x. Okay, so let's look at the bottom of this page. This is page 11. So this says sketch the graphs of f of x equals 2x minus 3 and its inverse. Okay, so here's what I'm going to do. I'm going to create an XY table, and I'm going to use two different colors. I'm going to use red for the original one, and then green for the inverse. So if you want to use color pencils or markers or whatever, you can do the same thing, because we're going to be drawing two different graphs on each coordinate grid. Now, I'm going to take the original function right here, and I'm going to create an external function. So let's go ahead and let's plot these points and go ahead and sketch the function. So the domain of this function, and let's draw an arrow there. The domain, if we put it in set notation, and we're not talking about just the ordered pairs for this one, we're talking about the actual domain. So the domain is the x values are all real numbers, or we could say -infinity to +infinity. The range is also all real numbers, -infinity to +infinity, because it goes forever up and down. Now, the inverse, because I haven't taught you how to find the inverse algebraically yet, I want to wait, and we're going to come back to this one later, but we will do the new domain and new range, and we will sketch the inverse. So if I did the inverse, then the x's would become the y's and vice versa. So really all I would need to do is just switch these numbers negative where they would intersect. So let me get green. And so there's my inverse function. I'll draw an arrow here too. And if we did draw, and I'm gonna draw y equals x. I'll do it dotted. I'll do it in black. If I can get this right. So here's y equals x. And you can see that they are reflected across that line. So they look correct. The new domain is the same as the old range, which they're both just, let's see, this can be green, negative infinity to positive infinity, and same here. Now, is the inverse a function? Well, it passes the vertical line test, so the answer would be yes. And if you'll look too, the red one, if we wanted to know if the inverse was a function without actually sketching the function, the inverse function, we could look at the red line and say, okay, does it pass a horizontal line test? And the answer would be yes, that it does. So this is what we call one-to-one, and the inverse is also a function. Okay, next one. I need to give you the there we go. Okay, so in red, I'm doing the original. So it will be y equals x squared, let's do minus 4. Okay, so let's do that one first. This is going to be a quadratic. I want to show you something before we actually sketch this one. Let me go over to Desmos. And I want to show you that, let me see if I can move this over a little bit. Yeah. Okay. So here is a way that you can sketch a function and its inverse without having to actually do an XY table. So if you go to Desmos and you type in f of x equals, and then we're going to put our function in here, and then you type in x equals f of y, that's going to show you the function and its inverse. So I'm going to type in x squared minus 4. Okay, and then let me see if I can make this, if I can zoom out a little bit. Okay, there we go. Okay, so the original's in red and the inverse is in green. And if you notice too, I'm going to make a dotted line of y equals x, and you can see again how they reflect across that line, not across the x-axis. It doesn't flip this way. Let's look at just the red one. Do you see just the red one? Do you see it doesn't, when I make the green one visible, it doesn't, the red one hasn't flipped upside down, but it has reflected across that dotted black line. So now what I can do is I can look at some points. I'm going to make the green and the black invisible again. I can look at some points, 0, -4, -2, and 2, go back over here and just graph those points. So I had, let's see, original I had 0, 1, 2, 3, 4, -4. I had -2 and +2, I think. Let me make sure I did that right. Yep. Okay, and looking at the transformation, that would be right. So I'm going to sketch this one in red, and I'm really terrible at this, but just sketch it as best I can. And then again, I'm going to, and you don't have to do this part, but there's your y equals x. So let's go back over here and look at the green one. The green one has, the vertex is at -4, 0, and I have a y-intercept of 0, 2, and 0, -2, so -4, 0. Let me get green. -4, 0. I have 2 and -2, and so this is my inverse. And so the red graph, the domain, all the x values, that would be negative infinity to positive infinity. The range, it starts at -4, and it's included, -4 to positive infinity. We're going to do the inverse equation later. We're going to come back to it. The new domain and range. The domain starts at -4, goes to positive infinity. The new range, the new range is negative infinity to positive infinity. And if you notice, domain, range, domain, opposite, domain, range, and then range, domain. So these actually do switch again. Is the inverse a function? Well, the original one wouldn't have passed a horizontal line test, and the inverse doesn't pass a vertical line test. The answer is no, it is not a function. Okay, our next function that we want to look at is y equals square root of x. And I'm going to go on over to Desmos again, and you can keep this exact same thing up here and just change out this first function, and it's going to show you the inverse. So let me show you, let me see. I'm not sure if I can't make the window bigger, but I can move it down. There we go. Okay, so in order to enter a square root symbol, you want to go to the keyboard at the bottom, click functions. If it's somewhere else, oh, there it is right there. I'm sorry, square root of x. I didn't see it earlier. There is another way to do it. There's a way to do a cube root also. If you go to functions on miscellaneous, you can do cube root, fourth root, whatever right there. Anyway, so I've entered square root of x, and both of these share the point 0, 0 and 1, 1. There's your y equals x line, and you see how they are reflected over that line. If you remember too, the red one is our original, and it has a point at 4, 2 also. So let's go back over here and sketch those real quickly. Move this back up. This doesn't really line up right with my Desmos. So, okay, so let's see, the red one was 0, 0, 1, 1, and 4, 2. So it's here, and it goes that way, and it does stop right there. And then the green one, its inverse, has 0, 0, 1, 1, and 2, 4 in it. So it's kind of like that. And then I'm not going to draw the y equals x. We saw it on Desmos. Okay, so original, domain. Let's look at the red. Domain, the x values. Well, let's do this first. Does the red one pass a horizontal line test? Yes, it passes. HLT. So I know that its inverse will be a function. So I can go ahead and answer yes right there. And that's how you can do that. So domain for the red one is going to be, it starts at 0 and it goes forever towards positive infinity. So 0 with a bracket, positive infinity. Range is same thing, right? Yep. 0, positive infinity. And then the new domain, it's got to be the same thing because the old range is going to become the new domain. And then the new range is the old, I might have said that backwards. The old range is going to be the new domain, and then this one is going to be the new range. So you just switch them. But they're the same anyway. Okay. Okay, so you have 2 more at the bottom of your page, and I'm going to give you the equations for these, and then I want you to try them. So the one of them is going to be y equals negative x squared plus 1. So I want you to try going over to Desmos, type in f of x equals, and then y equals f of y, excuse me, x equals f of y. Put that in. Put that equation in right here and see what they look like. Go ahead and sketch them. Just try that one. And then the next one is going to be, let's see, y equals 2x minus 4. So this is linear. If it's a line, I'm going to just tell you the inverse is going to be a function also. So I want you to try that. Now I'm going to move on to finding inverses algebraically. This is not going to take me long. So hopefully I can get through this in 30 minutes, maybe a little bit more, but I'm gonna aim for 30 minutes. So to solve or to find an inverse algebraically, in other words, using algebra, these are the steps. Here's what. Yeah, we can follow those, but the whole f of x and and all that might be a little bit confusing. Here's what I want you to do. I'm going to do this in red so we can see what I'm changing. Okay, so here's what I want you to do. I want you to change this to y, and you can write over it or you can rewrite it. So we're going to change this to y equals 2x. Then we're going to switch the x and the y. So I'm going to put x over here and 2y here. And then I'm going to solve for y. Okay, so divide by 2, divide by 2. So y equals x divided by 2. The other way you can write this, and you might see it like this on an exam, is there's a 1 here. I can bring this x over here because it's in the numerator. So you might see 1/2 x instead of x divided by 2. That's it. So change the f of x to y, switch the y and the x, and then solve for y. Okay, let's try another one. Okay, so let's make this a y. And we're going to rewrite this. Y equals 7x plus 1. And then switch the x and the y. Put the x here and the y here. Okay. Now, just solve for y. You can also rewrite this and move all this over here if you want to. If that makes it easier for you to have the y on this side, that's fine. Some of you are thinking, why can't I just solve for x? You can, and then you can switch it later if you want to. So, let's solve for y. Subtract 1 from both sides. Well, when I subtract 1 from x, I can't combine those in any way. All I can do is rewrite x minus 1, okay? And then I'm going to divide by 7 on both sides. Okay, so here's the trick. I get y equals x minus 1 over 7. I'm just going to tell you, on an exam, you're not going to see it like this. What you're going to see is you're going to see where they've divided the x by 7 and the negative 1 by 7. So here's how it's going to change. Think of there being a 1 right there. Write 1/7 x and then minus 1/7. So this is how you're going to see it on an exam. I would not count this wrong, but on the exam you're just not going to see it. So if you're looking at multiple choice and you're looking for the answer, this is how it's going to look. All right, let's try another one. Number 3. Change it to y equals x cubed over 8. Okay, and then switch the x and the y. X equals y cubed over 8. Now solve for y. Well, the first thing I need to do is the last thing that was done. If you're having trouble with this, what you need to do is think to yourself, okay, y was cubed and then it was divided by 8. Well, how do I undo divide by 8? I multiply times 8. So if I multiply times 8 over 1 here, and I multiply times 8 over here, I get 8x. And then these cancel out and I have y cubed. Well, how in the world do I undo cubed? Same way I undo squared, except it's a cube root. So I need to take the cube root on both sides. So my inverse is going to be the cube root of 8x equals y. And then you can switch them around if you want to. So this is the inverse of this one. All right, let's look at number 4. Okay, so let's change this to y equals square root of x minus 4, and that's all under that radical. Switch the x and the y. X equals square root of y minus 4. Now I need to solve for y. I want you to think about this. I am going to go through these steps. So let's look at this. What was done to this y? First of all, 4 was subtracted from it. And then the square root was taken. Okay. Have you ever tied a rope in a bunch of knots and tried to untie it? You have to undo the last knot first. You can't undo the first knot first because that won't work. So the last one that you tied is the first thing you have to undo. That's kind of like this, this here. This was the first thing that was done, and this was the second thing that was done. So that means this right here needs to be the first thing that we undo. So we need to undo this square root. Well, how do you undo a square root? You square it. So if you square both sides, that will undo that square root. So then you have x squared equals y minus 4. Then I add 4 to both sides. So y would equal x squared plus 4. So that right there, y equals x squared plus 4. There is one step that I didn't tell you to do. And that is to rewrite this instead of y. Rewrite this as that equals 1/2 x, like that. So that's actually technically correct. I forgot that step. So let's go back through these and do that. So we have the inverse of f of x equals 1/7 x minus 1/7. So that is actually officially the correct answer there. Let's see, and over here we have the inverse of f of x equals the cube root of 8x. And then number 4, we would change this to the inverse equals x squared plus 4. You kind of see that. You see where you undo that, square it, and then you add 4. Those are the how you undo that equation. All right, I want to leave number 5 for you to try. I want to go through number 6 with you. That instead of f of x equals x minus 1 over x plus 5, switch the x and the y. So we have x equals y minus 1 over y plus 5. I'm going to write this over 1 because over here we have this fraction and the y is in both the numerator and denominator, and I need to solve for y. So I'm going to use cross products to try to get rid of the fraction first. So let's see, let's do the x times y plus 5 equals 1 times y minus 1. And then I'll distribute the x, xy plus 5x equals y minus 1. Then I think I will try subtracting y from both sides. Minus y equals, and then I'm going to subtract 5x over here. Negative 5x minus 1. Okay, so then I'm going to factor out a y from this side. Okay. Now I can divide by x minus 1. So that cancels. Y equals. Let's just rewrite this first. So as long as I get y by itself, I'm done. I don't have to do anything else to this. Like, it looks like, oh, I need to like divide by x minus 1. I really don't. I've got y by itself. So that means that the inverse of this function is negative 5x minus 1 over x minus 1. And I went ahead over to Desmos and entered, where I can enter my inverses. I entered the original function here, and then I graphed the inverse function, which is in blue. Let me see if I can back out of this a little bit. This is an interesting looking function. It's like a double reciprocal function or something. Okay, so there's the original and the inverse, and then I typed in what I got for the inverse when I solved it algebraically, and that one's going to be green, and you can see that the green one fits right over the top of the blue one, so that is a correct answer. Let's see, where were we? Let's look at this one. I wanted to write the inverse. Well, we can look at this one first. I wanted to write the inverse and figure these out algebraically. So let's do that, and then I'll get to the last page in your notes. I'll do this in a different color altogether. So if I've got f of x equals 2x minus 3, I'm going to change that. I'll do it over here. Y equals 2x minus 3. Switch the x and y. Oops, 2y minus 3. And then solve for y. So let's add 3 on both sides. X plus 3 equals 2y. and then divide by 2 on both sides. So I end up with y equals x plus 3 over 2. But I want you to remember, it's not going to look like that on an exam. You need to separate these and divide each of them by 2. So it's going to be y equals 1/2 x plus 3/2. So then let's go over here and let's say, okay, then the inverse of that function is 1/2 x plus 3/2. First, the 1/2 x plus 3/2, you can go back to Desmos and type in the original. I've typed in the original up here at the top. And then I have my, where it shows me the inverse automatically. But then if I type in what I got for the inverse, for the equation of the inverse, then I can check to see if it shows up on top of that green line. So we got, let's see, 1/2 x plus 3/2. And you see that that orange line that I just did, it showed up right on top of the green line. I can go over here and make the orange line invisible and see that that green line is the same as the orange line. So that's how I can check to make sure that my equations are actually inverses. So if I have this green line in here, which automatically gives me the inverse, and then I type in what I got for the inverse, and if they're the same graph, then I've done it correctly. Okay, so the last page in your notes is page 14, and to be completely honest with you, you can kind of ignore this part right here. What I'm going to do is I'm going to show you that on an exam, on a benchmark, a lot of times what you're going to see is you're going to see two functions like this f of x and this g of x, and they're going to say, verify that these are inverse, or they're going to ask you, are these inverse functions? So what you need to do is you need to take one of them and find the inverse of it. So if I take this first one and I find the inverse of it and I switch this to y equals x squared and then x equals y squared and then I solve for y, I get y equals square root of x. Well, y equals square root of x, or f of x, if I change that, equals square root of x, it doesn't matter. You're just looking at this part. Does that part match that part? And if it does, your answer is yes, these are inverse functions. All right, let's look at another one. So if I were to take f of x equals 3 minus 4x and find the inverse of it, I would do y equals 3 minus 4x, switch that, and then, whoops, sorry, that should be a y, and then solve for y. So I need to subtract 3x minus 3 equals negative 4y, divide by negative 4. Well, y equals x minus 3 over negative 4, but look at this. Now this doesn't look the same, but what if I take this and I multiply it times negative 1 over negative 1. That's the same thing as multiplying times 1. Negative 1 divided by negative 1 equals 1. If I were to do that, if I were to multiply negative 1, numerator and denominator, I would get negative x plus 3 over 4. Well, negative x plus 3 is the same as 3 minus x. All I did was just switch them over 4. So this and this actually do match. So my answer would be yes, they are inverse functions. I want to maybe try one more. I think we might have already done this one, didn't we? Let's see, we multiplied times 8. And then we took the cube root. Oh, okay. So this would be no, because y would be the cube root of that whole thing with the 8 and the x under the radical. And this one, this does not match this, so your answer would be no, these are not inverse functions. All right, sorry, it was 35 minutes instead of 30. I tried. Anything else that I didn't get to, I want you to try on your own. We can work on them during class tomorrow as part of your classwork as well.